this is Norway. We don't yell, we don't make any noise. We just sit here with our hands folded in our lap. Don't ask us any questions. Do not make eye contact. We get scared and bolt. I'm from Canada, in case you didn't know, and we have a lot of deer that behave kind of the same way. As long as you're quiet, don't make direct eye contact. It's kind of like you're walking along the path and you see them and they see you. And like, okay, no sudden movements. We're cool. But don't take my picture or anything. My name's Udi Dahan. I'm Canadian. That means that we're kind of like Americans, just without all of the annoying bits. Speak very nicely, politely. We don't curse very much. And I'm going to be talking to you today about something called Cqrs, Command Query Responsibility Separation. Who's heard of Cqrs before? Everybody. Awesome. Okay, great. I apologize in advance to say that's the but different part of the talk. So if you've heard of Cqrs and you're doing Cqrs and you're kind of happy with what you're doing, you might not like everything that I have to say. Or if your boss is sitting beside you, this might be a good time to say, psst, go to a different talk. Because I'm going to be talking about a different style or a different way of approaching Cqrs than maybe you've done before. And we're going to start with a little bit of the background, some of the things you might have heard about Cqrs and how it looks and how to apply it. And we'll start describing alternatives to that approach, what problems Cqrs was meant to solve, what other solutions we have for them, pros and cons between them. From there, we'll put Cqrs in a larger architectural context so that you understand that it's not the only game in town, and how those things fit together with other things like event-driven architecture and publish-subscribe. And towards the end, I'm going to be showing you a different kind of application of Cqrs principles and thinking that fulfills a lot of why Cqrs was developed to begin with, but technologically speaking, or from an implementation perspective, it will not have nearly as many moving parts as what the traditional Cqrs looks like. So that's roughly what we're going to be doing over the next hour or so. Starting with the background. So who's seen this picture of Cqrs before? Yes? Okay, a bunch of you. Now, this is a slide that Greg Young put together to kind of describe the different parts of Cqrs. One of the things he intentionally did that I very much agree with, he put the client on the bottom. We're so used to seeing client at the top and everything kind of happen down from there that just kind of turning it around get people to take a second look and reevaluate more of their architectural principles. So I don't want you to get too hung up on this picture over here, because there's certain elements to it that you don't always need when going to apply Cqrs. But this is where a lot of people are coming from when going to do Cqrs. So why do people think that they need to do Cqrs? So one of the things that comes up repeatedly in all of my travels when I'm talking to clients or consulting or training or whatever, it's we need Cqrs because we need to scale. Now, scalability is important. I'm not going to say that it isn't, but a lot of times the context is, look, we've got a huge amount of reads that are coming onto our system, and the traditional way that we've built our software was sort of a big domain model that we use both for the commands and the query side of things, makes our queries kind of slow, and we're having difficulty scaling. That's why we find the idea of separating the commands and the queries to be really quite attractive, so that we can scale the queries independently of the commands, and we're like, okay, that's going to solve our problems. Other reasons why people like the idea of Cqrs is the promise of simpler code. Who could not like the promise of simpler code? So instead of having big, monolithic, complex domain models, we'll have a smaller command model and a separate read model, and each one of those will be focused on its own little piece, and therefore it'll be simpler, easier to maintain, etc. And the third one is, well, everybody's doing it. The fact that there are so many of you here that talk about Cqrs or heard about Cqrs is a product of that kind of hype curve. And it kind of started more in the .NET territory with myself and Greg Young talking about it. But now there's people all over the world that are talking about doing it on the Java platform as well and integrating it into akka and actor models. And Cqrs has kind of become a thing unto itself. So don't want to spend too much time talking about that reason, but social pressure, it's important to realize that has some play towards the adoption of things. So what else could you do if you needed to scale? So I'm going to start actually not from the client side of things, the way that Greg put it at the bottom, but rather looking at the database side of things. Now, I know databases have kind of, especially relational databases, they've really fallen out of fashion over the past couple of years. It's like, you go to an interview and they say, so which databases have you used? You're like, well, I've used SQL. And they're like, and? And you're like, and what? It's like, you haven't tried any NoSQL databases and you feel so inadequate. It's like, it didn't used to be that way. Knowing a relational database was fine. But now everybody kind of wants to do something else. So this actually relates to standard SQL databases. There's this great thing that's called master-slave replication. Now, some of the problems in years even before Cqrs became popular was the popularity of object relational mappers. So who's using an object relational mapper of some kind or another? Okay, a lot of you. Now, don't get me wrong, I think that they have their place, but it bred a certain environment where it encouraged developers to kind of ignore what was going on in the database. What we did domain modeling and we did object mapping. All of the interesting stuff happened in our code. You start leveraging databases, people kind of look at you funny and say, right, and you're going to be writing stored procedures any second now too. And there's the sense that you do something at the data layer that's icky, that's wrong, that's unclean. If you're domain-driven, you write domain models and you map them, and that's where the power lies. And there's been, in my experience, almost a whole generation of programmers that have grown up without very much awareness at all as to what databases can do. One of the things that they can do is this thing called master-slave replication, where there's a write master, so anytime you're making modifications to data, the client library of your database is going to be updating the master database, and the database technology behind the scenes in a fully asynchronous fashion will be replicating those changes to one or more read slaves. And then again, when you go to query it, the client library just automatically connects to one of those read slaves and allows you to perform the query against that. If you look at it, it's kind of like, well, isn't that kind of command query responsibility segregation? I mean, we're not writing really any code for it. The database is doing it by itself. But we have a very nice scalability story. If we need to ramp up our reads, we can just add more slaves for those reads, and the master keeps churning along same as before. Now, again, this is a very old, fully supported database mechanism. It's not like oh my God, will I ever find a database that supports this revolutionary style of CQRS? It's like Postgres, MySQL, SQL Server, Oracle, throw a stone. Really, almost all of them do it. But for whatever reason, it's not in fashion in the CQRS community to talk about master-slave replication or doing really anything at the database level. So all I want to do, again, make you aware that there is technology out there that already does a lot of this type of read-write separation for you, out of the box, without you having to write any special code around it. It works, it's tested, and the greatest thing, you don't actually have to maintain that code, so it's not going to break. So that's one approach to start getting scalability for a read-intensive environment. Now, you still have the problem that if your code is doing really complex joins and whatnot in order to build up a query result from your schema, yeah, you could have a latency problem because each query is taking a long time because it's doing a lot of transformation. This isn't going to solve that. However, from a throughput perspective of saying, well, we could just rack up more web servers and rack up more slave database servers, so while it wouldn't improve the latency per request, it actually is a very good solution for throughput, of dealing with many more users doing queries and preserving the same level of latency across them all. So just make sure that you have that in the back of your mind when you're looking at designing your solutions. Second one. My machine seems to have decided to freeze. Apparently it didn't Cqrs correctly. Aha. There we go. Okay. Next option is database partitioning. So database partitioning is where you take your database, as you understand it, and instead of, and this is a common mistake, it's not putting one table on one server and other tables on other servers, okay? If you're doing that, you're asking for trouble, because now you're going to have to do, for any of your writes, a cross-database transaction, and that's going to be extremely slow. That's not what we're talking about here. What we're talking about is taking some rows of a table and putting them on one server, and other rows of that same table and putting them on other servers. Okay, so in essence, it's dividing up the data that you have in your database across multiple servers. Oftentimes we use some sort of natural key for the purposes of partitioning. So users whose name starts with A through D will be on server number 1, and E through K will be on server number 2. And to some extent, this is not as transparent as the master-slave replication that we talked about, but it's not a huge amount of extra complexity for your application code to be able to select what connection string am I going to use when going to perform this sort of action. Now, keep in mind, this will really only work if you don't need to do cross-record transactions. So it requires some level of partitioning of the business domain itself, because you no longer have a single master anymore. Each of these is its own master, or potentially master-slave replica set. So as long as you don't need to do transactions that span users that are called Udi and other users that are called Adam, then you're going to be golden. Partitioning tends to work well up to a certain point when you start to have just enough data that the uneven distribution becomes painful. Because as we know, users don't necessarily, there are not lots of them that are called Udi, and there are many more that are called Adam. So we may end up with a whole lot more load on that server than we have on that server. So that's not exactly what we want. And for that, there's a evolution of partitioning that happened since that point. It's called sharding. Very similar in terms of partitioning. Again, it's taking parts of our data and putting it on different servers. The difference is we don't usually use a natural key for the purposes of partitioning. We use some kind of sharding function. And the purpose of the sharding function is to take the set of data and to come up with good ways of evenly dividing it up. Sometimes it's as simple as a hashing function on an identifier, and then saying, all right, if the hash mod 12 is 1, then it goes to server number 1. Mod 2, server number 2, and on, mod 11 to server number 11. Okay? So sharding is kind of taking that idea of partitioning and making it more balanced. Again, both partitioning and sharding are now things that are available out of the box with a lot of your favorite database technologies, so you don't actually have to write a whole lot of code. The advantage of this, as opposed to the master-slave, as I mentioned before, is that now you actually have multiple masters. So you have already started scaling out your command side as well as scaling out your query side. And again, this is writing fairly simple, stupid code on top of it. I mean, like this simple, stupid. Not really getting very fancy at all. You might even go so far as to say, well, do we actually need a server? I mean, most databases today are perfectly happy listening over HTTP. So why exactly do we need to go through a web server in order to connect to a database, which in many cases we're already connecting to over HTTP anyway? Now, of course, the security guys, any security guys in the room? No, none of them. Okay, we'll make fun of them. They'd throw a fit if they saw this. Like, are you insane? That is not secure. You cannot expose your database to the internet that way. This is a logical deployment view. There's going to be 13 firewalls and network intrusion detection systems and dragons and unicorns with fire that are protecting this database from a physical deployment level. That does not mean we need to write lots and lots of code and distribute that over 15 different machines to make it secure. So that's a general rule of thumb. I try to talk about this almost in every single talk that I do. Think separately about your logical architecture and your physical architecture. Don't go introducing 15 different layers in between things just because you think you need that for security. In general, writing more code on more machines is less secure than less code on fewer machines. So, now that we've got that out of the way in terms of scalability, while this may appear to be an unscalable solution, understand that in essence it scales out by having more clients or more web servers and more physical database instances behind the scenes without us having to write a great deal more code. And it's supported by almost all the database technologies out there. So I hope in this first 15 minutes or so, I've been able to convince you that there are lots of other good ways of scaling both a read-intensive system as well as a write-intensive system without having to write very complex code. And it can really be this simple. So when somebody comes along and says, the reason I want to do Cqrs is because it's simpler this way, kind of say, really? Does that look much simpler than this? Or this? Oh no, it's more scalable that way. It's yeah, not necessarily. So, now to be clear, there's nothing about this that says you couldn't make a big monolithic client app that would be difficult to maintain. Or in this, to have your server code be a god-awful mess. But in terms of just pure technological scalability, there's a lot that databases can do. Spend some time looking at those capabilities, see what's right for you, before you start going down the path of Cqrs for the purpose of scalability. So as long as we've got that settled, we can now go back to the whole, but everybody's doing it argument. Okay? So allow me to pop up this picture of the everybody's doing it. This must happen at least once a year in Norway in every city. Right? That, you know, a bunch of kids are around this pole and they're daring each other to, like, I'm from Canada, I know what winter is. Okay? Minus 30 degrees, that's just sort of an average day. So yes, this happened in our town too. So the whole everybody's doing it argument, look at how many people are interested in Cqrs, it's the cool new thing. Please don't buy into the hype. Now let's talk a little bit about the architectural side of things, the additional architectural context around Cqrs that influences Cqrs. So, layering. God, how I hate layering. Layering is one of those ideas, it's an old idea, it's been around for a long time, which, if you just boil it down to its essence, is just separation of concerns. That's really it. It says keep user interface-centric code separate from business code. And keep your business code separate from data access code. Separation of concerns. Somebody said, wouldn't it be nice if we could visualize that some way? And then they created this concept of layering. But there's really nothing about separation of concerns that says this goes on the top, that goes on the bottom. You can cross layers, you can't cross layers, and all of that. Do not get hung up on layers. Focus on the separation of concern side of things. You'll be in good hands. Don't worry too much about the layering side of things. But one of the areas where things are interesting, there have been some development, and you're probably all familiar with this thing called domain-driven design. Who's heard of domain-driven design? Yes, excellent. Problem is, a lot of domain-driven design ended up being kind of caught up in the discussion of layers. One of the things that I see that is not used nearly enough in people that are, or by people that are aware of domain-driven design, is value objects. Value objects are just this wonderful little pattern for capturing a bunch of complexity in your domain and putting it somewhere that you don't really have to worry about layering anymore. So for example, an address value object. If you have two objects with the exact same address data, they are equivalent. They are equal to each other. If you have two objects that represent money, 100 kroner is 100 kroner. Doesn't matter, you have two different objects, but you can start putting logic in there that surrounds this data structure of, heaven forbid, a float. Okay? Do not use float for money. Please, please, please. You'll thank me later. Create a data structure for your money. Start putting some logic in there. And a lot of the types of calculations that you might have had in your quote-unquote business logic is now put in a nice, clean place, highly encapsulated, highly reusable as well. And if you want to hear my thoughts about reuse come Friday, believe me, I don't like reuse. Then there's this thing called anti-corruption layers in DDD. I crossed out the word layer. I hate layers. Don't think of them as anti-corruption layers. They're anti-corruption components. They're there to be the code that translates between the yucky rest of the world and your pristine, beautiful code. Back and forth. Which layer does that go into here? None of them. It is a component unto itself. You could say it's off to the left side, it's off to the right side. Sorry, you're the other way around. Left side and right side. Don't focus on layers. Anti-corruption components, extremely useful when you need to integrate with any other system. Also, one anti-corruption component per system. So if you're integrating with 3 systems, you have 3 anti-corruption components, each of them focused on the craziness of each of those other systems. If you use the term anti-corruption layer, you're going to have this tendency to try to put all of that code in the same place and start reusing stuff all over the place. Let my American side get the better of me for a moment. So start arranging your code. There are enough other small patterns at place that you can use to partition the complexity of your software without going full-blown Cqrs or kind of asking yourself, well, which layer does that go into? Anytime somebody on your project asks, which layer does that belong to? Answer, it doesn't matter. Let's have it in its own component and just manage the dependencies with that component well. Said, no, but it would be really helpful for our diagrams if we could say which layer it was in. Say, you know what's great about PowerPoint? Doesn't have to compile. You don't have to maintain it. You can put whatever you want in PowerPoint. So ultimately say, well, the question is, so where do we put it in PowerPoint? Say, well, are you going to be looking at that PowerPoint? No, but managers are going to be looking at it. They don't know anything. If we left it out, they wouldn't ask. They say, where is it? It's in the middle layer. Oh, okay. Don't get hung up on the which layer do I put it in for documentation purposes. Anybody who actually wants to know how the system is built should be looking at real dependencies between things, probably driven off of some static analysis rather than PowerPoint pictures. Third thing, really important part of domain-driven design that doesn't get talked about nearly enough, subdomains and bounded contexts. Now, these subdomain bounded context things are a point of some contention. Me and Eric have been arguing for years about how to define each one of these things and how to map them together. Good news. Last week at the DDD Exchange in London, I sat down with Eric and he said, Udi, I agree with you. It would be ideal if we can come to a mapping, a good one-to-one mapping between subdomains and business components. The rest of what he said I'm going to leave out because it clouds my point. When you are working on a new software project and these things are under your control, look for how does the problem domain partition and break apart into separate subdomains, and then look to create bounded contexts where you have a one-to-one mapping. One bounded context, one subdomain. Another bounded context, another subdomain. If you can even get close to doing that, it's worth the effort. For the parts where you can't, that's where your anti-corruption components come in. That's when you have some third-party crappy thing that you can't really control. That's where you put the anti-corruption stuff. But for all the stuff that's under your control, try to preserve that kind of mapping between them. Now, what does that mean? What does it mean to actually do that? So, this idea of subdomains, a small part of your problem domain, bounded context, ultimately the solution part that maps to that. When we say that we want to have a one-to-one mapping, it means everything that belongs to that part of the problem domain should sit in one subdomain, including things like the user interface, starting way up at the top of your app. Instead of thinking of your UI as a single layer or as a single project, imagine it being built of lots and lots of little components. That each screen is kind of a composition of widgets, and that widgets like the price can appear in multiple screens. Now, I've talked about UI composition for years, but I have to spend some time on it because it really is a crucial part of avoiding coupling right from the very top of your app. If you can decrease the coupling from the top, it's going to be able to flow through really quite nicely down all of your other layers. So a lot of the data flow, a lot of the coupling that we see in our systems is very much top to bottom. I mean, we've all had that case where the business says, you know, I need just one extra field. And you're like, oh, okay, just one extra field. Well, I need to add that field to the database, and then I need to update my mapping in the data access layer, and update my domain entities in the business logic layer, and update the DTOs in my API, and update the view models in my UI. And there's always this sense that I must be doing it wrong. If I have this much duplication, something in my architecture is wrong. And the answer is, you're right. You have too many layers. Part of the reason why you're creating so many layers is because you think you need to try to decouple along these vertical axes. But the reality is this subdomain bounded context pair, it's not tightly coupled, it's highly cohesive. Remember those object-oriented principles? Said you want objects that are loosely coupled with each other, but highly cohesive. Cohesive is that internal strong encapsulation. What a lot of times people have mistaken to be coupling between layers is actually cohesion that people have been tearing apart. They've taken something that wants to be together and have been tearing it apart. And it's like splitting the atom. It makes a big, gigantic mess. It wants to be together. It's highly cohesive. The fact that you're creating more and more layers, you're just giving yourself more and more work. If you allow it to get together because it's one bounded context, you can collapse a bunch of the layers and make your code quite a bit simpler. One of the guidelines for that, indeed, is looking through the data in your user interface, saying, if price is part of one subdomain, then that means everywhere in my system where price appears, I should probably have that in the same bounded context and just recompose yet another widget of the UI in another place. Now, there's 1,000,001 UI composition techniques, and they're very much related to the 1,000,001 UI frameworks that are out there, whether it's Angular or Angular 2 or Ember or Knockout or Backbone or. Each one of them has their own philosophy on UI composition. But in many cases, you'll have the ability to have not just one monolithic view model in your UI, but many small view models. And this is where I get to touch on microservices. You can think of these as the micro views that correspond to your microservices. Micro all the way to the top and micro all the way to the bottom. Now, when you do this and you start to say, okay, I realize that there is the possibility for some cohesion thing, maybe we make the bounded context be the more primary part of our architecture, and the layering kind of drifts to the sidelines. So there might be some layering in the different bounded contexts / microservices, but each one of these bounded contexts can be built differently. So we can have one that's kind of fairly simple standard client-server SQL database, like we talked about in the first section, and say, you know what, that scales just fine. Leave it alone. Don't go trying to over-engineer that. We can have another one that is a little bit more complex, that's doing something based on sharding, and a third one that's doing some NoSQL coolness because, well, we want to do NoSQL on a project so that our CV will be up to date. Now, in dividing these things up, what you'll find is the more cohesive you make them, the simpler they're going to be internally, but then that's going to drive you to some event-driven interactions between them. So things that might have been monolithic in the past, if we're talking about, again, the trite retail domain of purchasing an item, so I mean, you mean to charge the credit card, and you need to ship the product, and you need to update the customer loyalty program, and. So in the past, in say a traditional layered architecture, you would have had that big, gigantic domain model that does all of that together. And you'd have lots and lots of objects and lots of relationships between them. But as you move towards more of a bounded context model, you might say, you know, after we charge the card, we don't have to ship the products in the same transaction. We could publish an event saying, customer charged for order, and then that event propagates to another bounded context, and that bounded context opens its own little transaction and starts the shipping process. And in parallel to that, the loyalty program is also processing that event and crediting the customer with points. So we get some nice parallelism between these bounded contexts, and the domain model of each of them is quite a bit simpler, and the database is also quite a bit more narrow. So you'll start to see opportunities for more event-based reactive type of interactions between your bounded contexts, the more autonomous and cohesive you make them. And that's where you look for some type of publish-subscribe environment to help out. And that's going to be all I'm going to be saying about in-service bus, so, you know, product pitch over. Now, moving on to some of the rest of the patterns, it's important to realize that the bounded context that you come up with and the combination of patterns that you use is really going to be different in every single project. People look for a kind of cookie-cutter model that they can apply from one project to the next to the next. And we sometimes use metaphors in software, and one of the worst metaphors is construction. That there is software construction and then there's software maintenance. That isn't really what software is like. A very big part of software projects can be thought of as a chef creating a custom meal, where the chef, which is you, has a conversation with the patron, says, well, what would you like to have for dinner? Now, if only the person could say, what I want is a steak, medium, I want mashed potatoes, I want veggies, and in the end I want a nice dessert. And then you just give them that. Whereas most of the interactions, it's kind of like, well, I remember I had a meal 5 years ago and it was kind of nice, so build me one of those. But instead of steak, I think I want something else. And you're like, and what do you want? I don't know. Give me some fish. Like, which fish? I'm not sure. What fish do you have? And you kind of build something and build something. They're like, no, that's not it. And you build something. No, that's not it. Then you give them something. They're like, yes, that's it. I need 500 of these in an hour. They're like, no, it does not work that way. We cannot just go live with the thing that I cooked for you as sort of a taste. And we really need to have this element of picking the right ingredients for the project. And it requires a much deeper understanding of the interaction between their flavors to be able to come up with something that will work for the business needs and will be able to scale and we can deliver it fast enough. And incidentally, there's no such thing as software maintenance, but I'm going to get to that later. Like, next talk. On to the CQRS approach within these contexts. So I've given a bunch of examples where you have solutions for scalability, but there is one primary case where it doesn't work. The place where things go wrong is when you have high contention domains. Remember what I told you before, that I said all of that partitioning and sharding works well as long as you don't have transactions that need to operate on different records in different databases. The problem with high contention domains is that you often kind of trip over those cases without really being aware that it's happening. So you kind of design a system and everything's working well and you put it through testing and it goes to production and users are using it and you're happy. You're thinking, okay, great, success, we can move on. And then a book comes out. That's the most popular book ever on the planet, including the Bible and all printings of the Bible. All of a sudden, the load on your system not only goes up, but it becomes extremely localized. It's not that now you have twice as many users buying books. It's now you have 1,000 times as many users all trying to buy the same book. And nobody really thought that that was a significant performance test that we needed to run, because when we think about scalability, we think big scalability, millions of books, millions of users, everybody buying everything all over the place. Contention is a really big problem that you don't know that you have it until it blows up in your face. And the logic that you wrote, and let's give an example of some inventory order processing logic. And again, this will work fine all through testing and all through deployment, where you say, all right, let's begin a transaction. First thing we need to do, we need to find out how many of these items we actually have in stock, because we need to check whether the user wants to buy more items than what we have in stock, because that's what just natural business logic. You can't buy more than what we've got. And if the quantity is more than what we've got, well, then update the inventory and decrement the amount and commit the transaction, right? Very simple. It works, it's tested, users are buying books, everybody's happy. But then what happens when 50 Shades of Blue comes out? The problem that you have is that select query. Because when you have lots of people running this transaction at the same time, they're all running the select statement in parallel. And then when you go to do the update, because you're smart about your transactions, you make sure that you have optimistic concurrency set up. So user number 1 gets in, buys a book. At the same time, user number 2 has already read how many books there are and goes to try to update the transaction. The database says, nuh-uh, you're looking at an old copy. Throws an exception at them. Optimistic concurrency violation exception. Again, if you wrote smart code around your data management, you'd say, oh, concurrency exception, all right, try again. And again, this works fine under low levels of load. But what happens when you have tens of thousands of users that are all doing this at the same time? You have all of these transactions in the database, all tripping over the same record. As a result of that, the connection pool is not shrinking down because the transactions don't complete fast enough. So the database is kind of sitting there saying, look, I've got like 999,000 other books. Would you like to buy one of those? I can give you one of those. It's like, but your connection pool is just, drip by drip by drip. All of it's going out. And again, the problem is this occurs at the worst possible moment. This is Christmas Eve, or this is Black Friday, or whatever other big event, with the new popular book that has just come out, and everybody's hammering your site, and your database connection pool has dried up, meaning anybody else who wanted to buy any other book, which they might have been able to, is now no longer able to connect to the database, and you're getting these wonderful exceptions in your log files, connection refused by the remote host. You ever had that exception happen to you, connection refused by the remote host? Now again, what do you do when you get that? You retry. And your poor database is sitting there saying, I just can't help you out here. And you're thinking, okay, what we need to do, we need more servers. So you start racking more web servers in the front. Doesn't help, because they're all sitting there bottlenecked on that same database server. Now, how do you solve that problem with the database server? You can't scale it out, because the problem is a single record. Ultimately, what you need is a bigger box with more memory so that you can have a bigger connection pool, so that you'll have more users waiting for the book inside the database than outside the database than before. This is why contention matters. It's like this mine that you have in your system. You don't even know it. It looks like everything's going great on your project. You deliver the software. All the users are happy. Business is starting to pick up. All of the business people are happy. They're starting to talk about what a great success this was, and you're going to get a promotion and everything. And then, I don't know, Oprah Winfrey comes along and does a feature on one of your items or your company, etc. Everybody hammers your site, and then it starts going down. And you're like, oh my God. This is, without, any Canadian would say, this is a big oh shit moment. Where all hands on deck, but the problem is you just can't stand it up fast enough. Now, this is the point where you might be thinking, well, we should have used Cqrs. Cqrs would have solved that. Now, the problem with Cqrs, the way that it's represented here, that even if you designed your command model to be the kind of thing that is able to respond and deal with that kind of performance demand, you have this query model that is optimized for something else. And what I've seen happen, even with companies that apply Cqrs to the letter, that when they trip over a contention scenario, they have the bottleneck arriving on the query side. That the background update logic from all of the commands and events cannot process against the query model fast enough because the query model keeps deadlocking on them. And then the query model falls farther and farther and farther behind. And while you can say, no, it's eventually consistent, believe me, users do not like looking at data that's 5 hours old. Like, your system is broken. It's like, no, it's not. Everything's working perfectly. It's just eventually consistent. 3 months after Christmas, everything will sort itself out. You'll see. And that's the problem, is that contention matters. What we need in order to resolve this is to move to a model that's kind of like that event storage thing that Greg talks about a lot, if you're familiar with it. It's to move to a model that is somewhat event sourcing-ish in nature. The thing that makes event sourcing really good is that ultimately what it does is it's a lock-free type data structure. It's an append-only data model. And as a result of that, it is not influenced by contention. So as long as you're replaying those events in event sourcing style, then things are not going to block each other. However, you're going to have a problem here. Because you see, when you try to introduce this technologically, if you try to re-implement the logic that the business did, meaning you have to guarantee that there's enough inventory on hand before processing the order, you're going to be, in essence, undoing all of the benefits that event sourcing could have given you. So you kind of want to make a loosely coupled technology to implement a tightly coupled business process. The problem here is the tight coupling in the business process. So even when going to introduce the technology, what's needed is actually a much more flexible business process. And that's the hard bit. The hard bit is for us as developers to explain to the business, no, this is not just a bug in implementation, this is a bug in the requirements. You're asking us to guarantee very strong consistency on a high contention domain and to scale at the same time. I don't want to say that it's impossible, it's just extremely expensive. Just more and more bigger, gigantic database servers. So, for example, if you've bought books on Amazon, occasionally you might have gotten an email from them that says, oops, sorry, that item is out of stock. You'll be getting it later. Has that ever happened to you? Yes, the item is out of stock. That's the business getting more flexible. They didn't prevent you from placing your order, right? You click the button, and they ran through everything. They decided that the business process does not need to enforce inventory consistency. Say, we're going to assume that it's okay, and in the worst case scenario, we'll apologize afterwards. Once they remove the locking from the business process, then absolutely the technology can be non-blocking as well, and everything will scale beautifully. But here's where things kind of come full circle, is that once the business process is no longer blocking and highly consistent, you can introduce much simpler design patterns for this. So for example, you could create an append-only data model, something like this for your inventory, where we have very simple, standard relational database, nothing fancy. We have a product ID, and instead of storing a single record with the amount of inventory for each product ID, we store the delta. Every time somebody makes a purchase, we insert a new record with a -1, -5, however many items they purchased, and when they purchased it. Every time a supplier refills our inventory, we append another record with a plus equals to our inventory. And in that way, every single action, whether somebody's making a purchase or we are refilling our inventory, that can be performed without locking the rest of the table because, as we said, we do not need to enforce consistency at the time of the order. The last bit that we have is that element of saying, well, what about the query? Now the commands are really simple. They're non-blocking. In essence, we have separated the responsibility of the commands to be something that is non-blocking. We've made it really simple. So calculation that needed to be done in the past, remember the calculating the quantity part, we have transferred that responsibility now over to the query side. Not to say that the query side has become complex. I mean, all you got to do is the select sum of the deltas for that product ID, and now you know how much inventory you've got. And you know what? Databases are really good at performing a select sum operation. However, there's always a however, right? That's the thing. There's always a, but it depends. So this will work well for a lot of systems, but ultimately it creates a problem that that your data volumes become proportional to the number of orders that you've got. Whereas in the past, the size of this table was proportional to the number of items that we have. That's a huge difference, right? If you have 1 million products, yeah, you could probably fit that in one table. But if you're talking about storing all of the inventory movements for each of those 1 million products, that's not going to fit in a single table forever. And this is where you can do a kind of little hack. Now, Greg's talked a lot about snapshotting. You can do snapshots too. Because in essence, the history of everything that happened isn't really that interesting to this subdomain. So we could have some batch process that once an hour, once a day, if you will, goes through the database and starts cleaning out the history. So one of the things that it does is, first of all, it operates at a certain delay. It's not trying to compact things down to the absolute minimum. So let's say up to 5 minutes ago. Let's figure out what was the status of the inventory of a given item as of 5 minutes ago. And then we can truncate the history. And then finally insert a single record instead of all of that history in there. Very simple. And instead of having a database with trillions of records in it, it compacts down to having roughly the same number of records as the number of products that you've got, plus the last 5 minutes of activity, and you don't want to be interfering with that because that's where your contention is. So you may have spikes in terms of data volumes based on the last 5 minutes of history, and things are kind of going crazy, and you've got supplies and orders and lots of things that are happening. But you have this sort of tail compaction process that is keeping your data volumes under control. Now you might look at this and say, but you've just re-implemented Greg's event store. Now Greg would be offended if you said that, because he spent a lot of time and effort on his event store. Okay? There's a lot more that goes into it than that. But the reality is, for a lot of domains, you don't need very much more than this. Because we're talking not about all properties of the order, including the credit card information and the customer's credit score and their shipping address and all of that. We're dealing with a very small fragment of the data. That's that whole bounded context subdomain thing that I was talking about before. The inventory domain is loosely coupled from how we pay for things, which is loosely coupled from the product catalog and its properties, which is loosely coupled from how we ship things and the dimensions of the product, and on and on and on. So realistically, when we look at this, we say, in this subdomain, we've encountered something that has a high amount of contention to it. We've been able to, without writing really complex domain logic, I mean, I'm almost writing SQL here, just to really get the point across. I mean, if you wanted to, you could create a domain model, but seriously, what would your domain look like? A single object with 3 properties on it. Woohoo, there's a domain model for you. That's DDD in action. Don't be surprised if that happens. That's why bounded contexts are so powerful, because they take otherwise monolithic, really complex domain models, and they just slice them and dice them and leave you with really small objects without a whole lot of properties on them that focus on doing one thing. There's your single responsibility principle. And, incidentally, they're not very difficult to make scale. Not requiring all sorts of crazy infrastructure that nobody's ever heard of. Straight SQL databases. Now, again, going back to the deployment side of things, not really that complex for handling this specific fragment. And this is the part that used to be the hard bit. The high contention, performance intensive, crazy part of our system that almost brought our site to its knees the last time. Isn't it nice that we can kind of rip and replace one tiny microservice and micro view out of that, and voila, the system is scaling again. Now, let me just reiterate, why is this Cqrs? You might be looking at this, say, Udi, but where's the Cqrs? Because what we're doing here is we're analyzing things from the problem domain perspective, from the contention on the command side, and we're doing data modeling in order to alleviate that contention. It's Cqrs as an approach rather than as a cookie cutter. And as a part of doing that, as a part of alleviating the contention on the command side, we're transferring responsibility, tiny little bit of responsibility, to the query side. And now the queries are, in essence, giving us somewhat stale information. Just by virtue of the fact that when you do a select on a database, it's hitting an index. And an index is somewhat stale. So regular database technology, using a very simple sum, can give you that kind of query. And you can do the same thing with averages and counts and whatnot. to be able to give you what is the query side of things. You don't necessarily need to split the data model up into two parts in order to make it scale. You don't necessarily need to split the logic up into two parts, though fundamentally you could say, yes, the select query is on a different object than this code. So voila, CQRS. Query object, command object, but still sitting on top of a single data model. Don't get overly hung up on, but I need events, and I need to have a somewhat stale query model, and I need to design the schema. Don't come at it from that perspective. Always start from the bounded context. The bounded context will keep things small enough for you that you won't over-engineer it. So, quickly summarizing some of the things that we said before. CQRS, from a background perspective, very interesting approach that's helped people reevaluate certain assumptions they've had about how they write code. But, like all sorts of good ideas, the pendulum almost always swings way too far and the pattern gets abused. That's happened with every single pattern that happened before it. For example, dependency injection. Remember when dependency injection came on the scene, and all of a sudden you started seeing constructors accepting 20 properties that were injected in there. And you're looking at that saying, no, that's not how you do dependency injection. They're like, what, we don't use constructor arguments? Like, no, constructor arguments are good. Like 2, 3, maybe, but not 20. They're like, yeah, look at how dependency injection scales. Like, no, that was not the point. We're in the same kind of place with CQRS. It's not meant to be the kind of thing that you're operating on objects with 20 properties on it, and you're CQRSing it all over the place. Okay? Small subdomains, small bounded context, loosely coupled from each other, an event-based interaction between them within each one of those areas. Choose the right architectural approach. The main question to ask yourself, the main risk in choosing the design patterns for a given bounded context, one of the big ones, contention. Really sit down, talk to your business stakeholders, say, what risks do we have in terms of contention? Is it likely for us to have an Oprah effect, or an extremely popular thing, or a tall head, whatever you want to call it? Because those are the kinds of things that can crash your system at the worst possible moment and give your company a big black eye. And it's definitely not good for your career. Oh, you were responsible for the Sony PlayStation Network going down in the middle of Christmas. Well done, right? How would you like that to be your next interview? It's those kinds of things. It's the contention that really hurts. Not to say that CQRS elements, whether that's event storage or pub sub or query bundles, you can use a lot of those other elements in other bounded contexts too. But I hope I've given you some other alternatives, which are simple database approaches to get the scale that you need without nearly as much complexity. Now, I know I've talked about a lot of topics that are all fairly complex somewhat briefly, but if you want to learn more about this, we have these little video access cards for you in our booth, so come to our booth. It's the one with the big thing on the top, right down there. Come to us, get your video access card. You'll be able to get access to 2 days of videos of me talking about distributed systems design and coupling and service-oriented architecture and messaging, going quite a bit into more depth, not so much about CQRS, but about a lot of the surrounding patterns as well as project management stuff. So if you're interested in this kind of stuff, come see us at our booth, get the videos, and enjoy watching those. I hope I've entertained you a little bit and given you some interesting ideas to think about CQRS. If you want to check me out on Twitter, I'm at Udi Dahan, and we're the guys behind N-Service Bus and Particular Software, so come check us out. Thank you very much. Thank you. And if you have questions, feel free to come up and afterwards walk with me to the booth, okay? Because I got to clear this out for the next speaker.